Hi everyone, I'm Dmitry Meshkov and I'm going to introduce you Ergo, a comprehensive design of a cryptocurrency. I'll start from Ergo idea, our motivation, why do we want to launch a cryptocurrency. I'll speak about blockchain problems, what is wrong now with different blockchains, and later I'll start to talk about Ergo solution, how are we going to solve this problem. And for now, I'll start with Ergo idea and our motivation. And first, I'll introduce myself and our team. Our team is working on Scorex project. I think a lot of you know what is it. But its main idea is to fill a gap between theory and practice between cryptocurrencies and in theory for cryptocurrencies and blockchains and the practice. In theory, we have a lot of cool algorithm, probably secure, they have cool features, new anonymity, high throughput, and so on. But unfortunately, a lot of these cool ideas on paper are impractical. They assume synchronous network, trusted randomness, network time, or something like that. That is not true. And the idea of Scorex was to make theory more practical. It's a framework for prototyping of scientific ideas. We have implemented quite a lot of ideas, found problems with them, fixed some of them. But Scorex was a framework for prototyping. Now it's not just a framework for prototyping, because we already have two cryptocurrencies that based on Scorex. I think all of you knows about Waves cryptocurrency. It's, Sasha Ivanov introduced it in the morning. It's based on Scorex. Now their code is changed. They have their own development, but the initial design of Waves was based on Scorex framework. And also we have Ethereum Classic client that is also written in Scala and based on Scorex. It's completely different cryptocurrency. It's proof of work, it's smart contract layer, and so on. Two different cryptocurrencies production use Scorex in their source code, and we decided to do the same, maybe, and we call this project Ergo. The idea of Ergo is to make practice more theoretical. Well, in practice we now have thousands of currencies. Most of them have some ad hoc solutions. They just add some new feature without solid backgrounds behind it, and usually they are not secure. They're secure for now, but maybe in future when cryptocurrency will be popular, the attacker can find any vulnerabilities there. So our idea is to make cryptocurrency that is a combination of a lot of scientific ideas that complement each other, that help each other, and that allow to design scalable, user-friendly, decentralized cryptocurrency with these ideas. I'll start with problems and what is wrong with existing blockchains. Why do we need another one? Why don't we like existing blockchains? What's the problem? The first, maybe the most popular problem about blockchains is throughput. I think all of you know that Bitcoin throughput is very low. It's just few 2 or 3 transactions per second, and now all the blocks are full. There are a lot of transactions in unconfirmed transaction pool. And the transaction fees are very high, like $5 per transaction now in Bitcoin. Other cryptocurrencies are less popular. They have lower fees. In Ethereum, you should pay for about $1, but it's also quite a big fee for transaction. And as a conclusion here, well, existing cryptocurrencies are not ready for mass adaptation. It's not possible to build worldwide payment system on top of existing blockchains. You can try to do something, you can launch your business on top of some blockchain, but if your business will grow, you'll find this limit in just few transactions per second, and it's not production ready. It's not ready for worldwide payment system. Okay, that's about the first problem. The second problem is smart contracts. I think it's also quite popular topic, and all of you know about it. I'll start from Bitcoin script. Well, in Bitcoin, we also have some kind of smart contracts. We can attach a script to our output, and we can write something like this, where this money, these Bitcoins can be spent by this guy before concrete date, and after this date, another guy can spend it, or multi-signature, two from these three persons can spend this money. This is all possible in Bitcoin. However, instructions, its script instructions are hard-coded and quite limited. There are quite few of them. It's efficient, that's good, and but really possibilities are quite low. On the other hand, we have so-called general-purpose smart contract languages like Solidity in Ethereum. In theory, you can implement anything you want in this platform, but in practice, they're limited with total cost of all operations. In Ethereum, it is called gas limit, and you can't write complicated code in Ethereum smart contracts. And also, this gas limit is not fixed, it's floating, and miners can reduce gas limit, and it's known issues when during DDoS attack, miners reduce gas limit, and your smart contract that worked for a long time in Ethereum for before this now require more gas than this gas limit, and no one run your smart contract, and you're out of business, actually. And it's also quite difficult to predict what can you build in Ethereum or what you can't build on Ethereum because of these computation limits. You might think that it's possible to build anything there, but it's not true. But also these Turing complete general purpose languages are quite hard to estimate it's quite hard to estimate the evaluation time, how difficult it is, and this leads to continuous DDoS attacks. The same example about Ethereum and Atom, there were quite heavy DDoS attacks, and the network was almost down for a month. It's impossible to really to estimate all the possible computations, and Ethereum will always have problems with these DDoS attacks because now these computations are cheap, but they're really hard, cheap in price of gas, but they're really hard to evaluate and so on. And also a lot of possibilities leads to a lot of vulnerabilities. If you have a language where you can build anything, you can make mistake everywhere. And all of you know about the DAO problem, and it was a problem of Solidity smart contract language, not the concrete, smart contract. We don't like both this approach. I'll tell what we are going to propose, and I'll tell you about the last problem here. It's about blockchain and state. Well, you know that blockchain is just a chain of blocks. We add new blocks to blockchain, and it becomes bigger and bigger, potentially unlimited. But also, we need a state. We need a current situation in a system who have coins, which one are these, and so on. This state size also grows. It's graph for Bitcoin, and so more users we have more bigger state size we have. And why is it problem? Well, problem of state that it should be very fast. We should validate transaction according to the state. When we validate transaction, we should check that center actually have these coins. And when this state is big, it's a problem for miners. Why? Well, first because they should keep it in memory to validate transactions efficiently, because if they don't validate transactions efficiently, their hardware is stale, they do not try to generate new blocks, and they lose their money, their hardware is stale. And this leads to mining centralization. It's not possible to mining on commodity hardware. You can't mine on your laptop because you don't have such a lot of memory in it. Another option for miners is to decide not to keep state at all. It's also known problem for Bitcoin. It's so-called SPV mining. You, as a miner, you might trust to other miners that their blocks are correct and generate empty blocks. While you can't validate transactions, you can still create valid blocks if there are no transactions in it. And in 2015, we had big forks in Bitcoin, 6-block fork, starting from incorrect block. And for now, it's very big vulnerability. Most of services require just 2 or 3 confirmations. 6-block fork allows to double spend your money. But even worse, that big state and blockchain is a problem for users. First, they can't validate blockchain on low-end hardware. It's not possible even to keep this data on your mobile phone. Even just state, you don't have gigabytes, few gigabytes of memory on a regular smartphone, and it's impossible to use blockchain trustless in your mobile phone. You can still validate blocks on commodity hardware on your laptop, but it's still validation will be very long. It's not user-friendly. You do not want to wait a lot of time, an hour before you can just send the money. And more and more users move to centralized services. Nobody, or almost nobody now, run full node on their laptop. Most of them go to some web wallets like Blockchain Info and keep their money in this web wallet. And that's really a big problem because it's a point of centralization in cryptocurrency. If this Blockchain Info will be broken, the attacker can steal a lot of money from different people. And in addition, while Blockchain Info is also a block explorer, he can hide stealing transactions from Block Explorer, and nobody can notice that money are actually stolen. We have one information on this front end on Blockchain Info, but really we have different data on blockchain itself, and that's a point of centralization. So unfortunately now we do not have a decentralized network like shown at the left. We have a network like shown at the right. We have a more or less centralized network of mining, quite a few of very powerful computers, and regular users do not join the network. They just try and trust to these powerful miners. They do not validate transactions. And finally, I'm going to tell you about Ergo solution. How are we going to solve this problem? I'll start with a general idea maybe about our solution. General idea is to make asymmetric design while miners generate blocks and also generates proof for these blocks. It's almost the same as we have, for example, proof of work. Miner spent a lot of work to generate a block, and he produced a small proof, just a block, and we can validate very fast that the miner actually did this huge amount of job. We just calculate hash, we check that it starts from a lot of zeros, and validation is very fast. We are going further. We are going to produce proofs for transactions in a block and also blockchain itself. So light nodes should check miner proofs. They prove that miner made correct job for current block, that light nodes check that transactions in the block are correct. It's just calculating few hashes. And also light nodes validate that the whole can validate proof of the current blockchain. They can check the proof that the current that the concrete block is the best in the blockchain, that this is really the best chain in the network. And I should emphasize here that there is no trust between miners and the light nodes. Light nodes validates everything. Miners can't change state, can't put incorrect transaction in a block or something like that. It's two-party system where we have miners who generate proofs and light nodes who check these proofs. I start from full chain design, full node design. We have also ideas here how to make full nodes and miners more useful. The first idea is roller chain. It's idea of Alex Chepernoy, co-founder of Ergo platform. And now this idea is under construction. Second version of protocol is coming soon. But the idea is that actually full nodes do not need to keep all the blocks. They need to keep just header chain and a fixed number of last blocks. It's possible, it's even possible in existing systems like in Ethereum and Bitcoin, and both of them have this flag in config, but their security guarantees are not so good because they they do not enforce to keep these blocks. They need altruistic nodes that keep all the blocks. In roller chain, we do not have altruistic nodes that keep something for free. You should keep, or you don't, or you shouldn't. Yeah, and roller chain allows fast bootstrap. You just need downloads 40 megabytes of data and a fixed number of last blocks, and you are synchronized with the network. That's cool for blockchain size, but also I mentioned that there is a state size, and we are going to limit its size with economical reasons. It's a new kind of economy, space-scarce economy, as we call it. The main idea is quite simple. You know, it's similar to common storage renting model. Well, for now in Bitcoin, you can put something for this blockchain forever. You can put something to state, and it will be kept there forever. Your outputs are kept there forever for free. Well, you pay once for this, but it's not healthy situation. You should pay for something like gigabyte month or byte blocks in case of Bitcoin, in case of blockchain systems. So our idea is to pay for some data time, byte blocks, and it's a fee model, but it allows to control state size with this price, and also active users are incentivized because you pay money for keeping something in state. Lost coins are going back to economy. If someone lost his keys, now they are not stolen forever. It's possible to return them because this space-time fee return this coin to economy. And also a very important point to currencies that miners have predictable rewards. It makes money more stable and more secure. That's all about design of full node. Now I'm going to design of light node, and I'll start from state size. And I already mentioned that it's impossible to keep such a lot of data on your mobile phone, even if it's high-end mobile phone. But we found a solution. Our paper, we presented it on Financial Cryptography Conference this year, and we can fix this situation with the help of authenticated dynamic data structures. Well, the main idea here is that light node keep only root hash of tree, Merkle tree. I think a lot of you knows what it is, and the state become authenticated with this root hash. Is just 32 bytes of data, and when miner apply transactions to a block, to its states, for example, he had state at block n-1, he applied transactions to to a block and he receives state at block n. He also generates proofs that transactions are correct. These proofs are enough to validate that transactions are correct, that sender actually have these coins, who's trying to spend his coins. In case of Bitcoin, that output is unspent yet. And also, these proofs are enough to calculate new root hash. So light node applied to his root hash at block n-1, these transactions and proofs, and light node receive root hash at block n. It's just linear structure, and all the time, all you need to keep in your local storage is just 32 bytes of data, just the root hash of this state. The second idea I'm going to tell about light node is so-called proofs of proof of work. It was also presented at Financial Cryptography about a year ago, and it's a paper of Agilus Giais and others. It requires quite yeah, I'm limited in time, sure. It requires a different block structure, header structure, but you need just few blocks to validate the whole chain, to find the best chain. Just 30 to 20 bytes of kilobytes of data, and you can synchronize the network. You can prove that this chain is the best. This allows extremely fast bootstrap, and also this allows cross-chain proofs. It's important for side chains because if you are in chain A and you have chain B, you can put some proof that there was transactions in chain B. If you're in one chain, you can prove that something happened in another chain. This allows side chains, protocols, and so on. And thus, we have full node security guarantees with just few kilobytes of data on light node, and I hope this will allow us to build user-friendly decentralized wallets. Nobody should use web wallets or something like this. Yeah, okay. Excuse me. Yeah, I'm continuing. The next problem I mentioned is smart contracts, and we don't like smart contracts like they exist now. And our idea is to build more rich, authenticated transaction languages based on Sigma protocols, and it allows to have threshold signature, ring signature, and so on for free. It's built-in Sigma protocols, and it will have a combination of environment proposition and crypto proposition, like spend this money after some time in transactions that have some money back, and so on. It's not Turing complete, but it's easy to analyze its costs before evaluation. You don't need to evaluate the code to run this protocol. And it's protocol friendly, but it's flexible. It's possible to build a lot of different protocol on top of our blockchain. And actually, it's important for throughput. Well, we don't think that there is some silver bullet in throughput solution, but we want to combine all the existing ideas. First of one is Bitcoin NG. As far as we know, it's the best idea for on-chain throughput. It's allowed to put like 1,000 transactions per second in the chain, but also on top of this blockchain, it's possible to build some off-chain protocols like Lightning or Sprites. It's also another popular idea. It allows to increase throughput in another factor of 1,000, like up to 1 million transactions per second. And also we have side chains because proofs of proof of work, and it's possible to launch different blockchain, more than just one blockchain, with the same token in them. This is also feature allowing to improve throughput for blockchain. Yeah, and one more important thing there is Ergo is database solution. We are going to use Aspen. I told that we are going to use Bitcoin NG, but actually we are going to use Aspen. It's the next version of Bitcoin NG protocol. And the idea is the same as symmetric, and miner should keep all the block. Its block now is like here, but if you are a service and you need just and you're going to put some data in a blockchain, you put it in subchain of it, like yellow subchain. And if your service is using blockchain, you put it only just in yellow subchain, and all you need to download is key blocks. It's just block headers like 80 bytes and yellow subchain. So it's very user-friendly for blockchain as database usage. And actually, we think about two chain, one for data and one for money, with sidechaining in it, because it's different blockchain usage by different parties. And current status of our research and prototyping. Well, we have prototyped roller chain, proof of work, and authenticated dynamic dictionaries. They are quite good. You like this. Economy model is on the stage of just a paper. The ESPN paper was presented this year. We just saw it recently. And transactions language is also on just a paper and some beginning of prototyping. But we for sure we will prototype it soon. I think it's the most interesting and recent research we are going to do. Okay, I'm limited of time. I'll leave this slide and check the conclusion. So combining these cool researches, we can have constant storage requirements, controllable state size on full nodes, but also full node security guarantees on smartphones and user-friendly light wallets, smart contracts including cryptography. I mentioned that you can implement something in Ethereum, but you can implement something in Ergo. There are things that you can implement in Ethereum, but you can't implement in Ergo. But also there are some contracts that will be possible in Ergo and that are not efficiently possible in Ethereum. User-friendly blockchain as database with high throughput, and at least we hope that we'll have a decentralized network. We'll make cryptocurrencies decentralized again with this and ready for mass adaptation. Thank you for your attention. Collaboration are welcome. There are our contacts. Thank you.
All right. Thank you very much. All right. Now, let's do all of that, and then so that I can understand in like 30 seconds. What is it in most simplest terms? What's the difference for me as a normal user?
Difference for you as a normal user?
Yeah, like what I need to know as somebody who doesn't know all the technical stuff.
Okay. It's ready for you. If you will need a lot of transactions per second, it won't be a limit. You won't wait transaction confirmation for days. Fees will be much lower than in Bitcoin now.
The fees? I understood that word. That's good.
Fees are very low, so
okay.
You do not need to wait a few days before your transaction will be put in a blockchain.
Okay.
For you as a user, it also means that you control all of your services, all your money on your mobile phone. You do not need to run full node on laptop, or you do not need to trust some web wallet like blockchain info.
Mm-hmm.
You control all of your money. It's fully decentralized. You don't need to trust anyone.
Okay, cool. Thank you. All right, I'm sure you have a lot of questions in the audience as well. So if anybody here, okay, first up right here on the second row, please.
You said that your system will recover the lost coins. Does it mean that coins will decay in time or will be somehow inflated?
Well, we have this model. It's possible just to take fees from every output. For example, when you put an output in Ergo, you'll pay a fee like like Satoshi per year for Bitcoin. We estimated it would be enough to take, in Bitcoin statistic, it will be enough to take 30 Satoshis per year from every output you put in blockchain. And it's a fee for you, but if you are active user of a system, it's nothing. But if you lost your coins, so you are trying to make an attack increasing the state. Also, there is no my presentation. I showed you a state graph, and also there was a big increase of its size in 2015. That was a DDoS attack, and also, Ethereum DDoS attacks in autumn based on increasing state size. So it will be much more expensive for the attacker to increase state size. It's almost impossible to make such attacks like in Ethereum and Atom. But for you as a regular user, well, nothing changes. Yeah.
Cool. Thank you very much. Any more questions? When is it going to be available?
Well, it's not an easy question. Well, now we are on the stage of prototyping and writing a paper. I hope we'll have comprehensive documentation till the end of the summer, and we'll start production implementation, and also most of prototypes at the end of the summer. So we'll start production implementation in September. I think half of a year will be enough to make it real.
And how can these guys, help you or be in touch with you, or what can you get out of them?
Well, we are welcome for any collaborations. If you want to join our team, please contact us. And if you want to maybe invest, we think about this. We also can contact and discuss details in private communications.
Okay. Any more questions? Yeah, there's one there.
Can we get your email maybe for contacts?
It was on the last slide. I have business cards you can take if you want.
Okay. Any more questions? There you go.
Thank you.
Cannot see if there's any more. Right. All right. In that, was there one? No. Okay. All right. In that case, thank you so very much. Give a warm hand of applause to Dmitry.
Yeah, thank you.